Hi students, I am Sumalata. In today's class, I am going to explain about Markovnikov's and anti-Markovnikov's rule. This is the most important rule. Just like you can feel it as a fundamental rule for the organic chemistry. Just try to watch complete video. Then you can able to understand what is Markovnikov's rule and what is a anti-Markovnikov's rule. When alkenes are going to be reacting with hydrogen halides, they will form alkyl halides. See, it is the alkene reacting with hydrogen halide will gives you alkyl halide. Here, halogen may be chlorine, bromine, or iodine. From these alkenes, if the alkene is a symmetrical alkene, if the symmetrical alkene reacting with hydrogen halide will gives you only one product. If the unsymmetrical alkene reacting with hydrogen halide will gives you more than one product. See, just remember the second condition. In the second condition, if the unsymmetrical alkene reacting with hydrogen halide, the addition of hydrogen halide onto the double bond followed by the Markovnikov's rule. Now coming to the what is Markovnikov's rule. Markovnikov's rule is nothing but when unsymmetrical alkene reacting with unsymmetrical hydrogen halide, they will gives you more stable product. During this reaction, the negative part of the hydrogen halide going to be attack on the highly substituted carbon present in the unsymmetrical alkene. So you can take one example. This is the propene. You can take CH3 CH double bond CH2. This propene reacting with HBr instead of hydrogen halide, instead of in place of X, I'm going to take bromine, hydrogen bromide. So what will be the product here? The product is CH3 CHBr CH3C. 2-bromo-propane is the major product. 1-bromo-propane also will form, but that will be the lesser one, minor product. CH3 CH2 CH2Br. This is the less one. This is the major product. Remember this. 2-bromo-propane is the major product. Now coming to the mechanism for this reaction. This mechanism involves mainly two steps. First one is the formation of electrophile, and the second one is attacking of electrophile to the carbon atom present in the unsymmetrical alkene. See, this is the hydrogen bromide will gives you H plus and Br minus. See, this is the electrophile. This is the negatively charged carrying species, nothing but this you can call it as a nucleophile. So here this is propene CH3 CH double bond CH2. So first of all, this H plus going to be attack on this double bond, so that this double bond shifted towards the terminal carbon here. So this carbon gets negative. So this negative charge attracts positively charged electrophile. So then they will gives you stable carbocation. See, this is the H plus ion attacks on this terminal carbon atom. Here positive charge will be generated, and this one is the stable carbocation. This stable carbocation later on abstracts Br minus ion CH3 CHBr CH3. See, this is the 2 bromo propane. This is the 2 bromo propane. This is the Markovnikov's rule. Then what is the anti-Markovnikov's rule? Anti-Markovnikov's rule is the reverse to the Markovnikov's rule. See, here I am going to write that one. The same um, propane you can take CH3 CH double bond CH2 HBr, then 1 bromo propane will be the major product here. Here also two products formed, but uh, here reverse to the Markovnikov's rule. There 2 bromo propane is the major product. Here 1 bromo propane is the major product. See, this is the 1 bromo propane. This is reverse to the Markovnikov's rule. Here, this reaction carried out by in presence of peroxide. Peroxide. See, if you see mechanism for this anti-Markovnikov's rule, it will follows by free radical addition. See, once you here, I am going to write R O R. This is the peroxy linkage containing compound. Then it will going to be uh, break down into as a free radicals. Two alkoxy radicals will be formed. This alkoxy radical further abstracts proton from HBr, then alcohol formed and the Br radical will be formed. Then this Br radical going to be attack on this um, propene. See, I'm going to write the remaining step here. Here the formed bromine radical going to be attack on this double bond. Then this is Br radical CH3 CH CH2 Br, and then again free radical will be formed at the middle carbon atom. So after that one more HBr going to be involved in this reaction. Then here also H radical and Br radical. This H radical going to be attack on this middle carbon atom. Then it will gives you 1 bromo propane. See, this is the 1 bromo propane. This is anti Markovnikov's rule. One more important point, from HCl, HBr and HI. From these three reagents, which one is going to be show peroxide effect, which one is not going to be show peroxide effect? HBr going to be show peroxide effect. That will not shown by HCl and HI. What is the reason? In HCl, the bond strength is more. The bond present between hydrogen and chlorine, that will be more, so that it needs more energy to break the bond present between hydrogen and chlorine. That one approximately 103 kilocalories per mole energy needs to the break bond present between hydrogen and chlorine. And if you go to HI, in this HI the bond present between hydrogen and iodine will be very weak, so that it needs less energy, that is approximately 72 kilocalories per mole. See, this is less, so that it is going to be react, it is going to be show peroxide effect. But why it's not going to be show HI? Because while going to the attack on the double bond, iodine radicals are here. These iodine radicals are reacting with each other. They will form I2 molecule immediately. That is the reason this will not show. So only that peroxide effect shown by HBr. And one more thing is addition of acids to the alkenes will also follows Markovnikov's rule. You can take one example, addition of sulfuric acid to the ethene, CH2 double bond CH2 plus H2SO4. This is the sulfuric acid, this is ethane. This sulfuric acid you can write like this for easy understanding. Sulfur double bond O, double bond O, OH, OH. See. So here this oxygen is more electronegative than hydrogen, so that it will attract bond pairs towards itself. So H plus and O minus will be formed. Then this double bond going to be break. Here it is the this mechanism mainly based upon electrophilic addition. Here H plus is the electrophile, so this H plus going to the one carbon, that carbon carries negative charge, and this sulfate ion going to the hydrogen sulfate ion going to the carbon carries a positive charge. So see, this is the CH3, CH2. See, this is oxygen, sulfur, double bond O, double bond O, OH. This is the ethyl hydrogen sulfate. This compound name is the ethyl hydrogen sulfate. So after that hydrolysis will be taking place. So this bond going to be break. Then alcohol will be formed, CH3 CH2 OH plus again sulfuric acid will be generated. See, this is about the addition of acids to the alkenes. So this is about complete Markovnikov's and anti-Markovnikov's rule. Some important points. I hope you are all understand about this one. If you have any doubts, post your doubts in comment box. Don't forget to like, share, subscribe. Thanks for watching. We will meet in the next class. Bye, all of you.